Welcome. We'll start with what is happening. There is a book published in 2019 by David Wallace Wells. The first line of the book is, "It is worse, much worse than you think." So what is happening? The Earth has warmed 1 degree centigrade, 1.8 degrees Fahrenheit since about 1880. That is well known by temperature readings having been taken all over the world since that time. What is worse than we realize is that the author reports that in the last 30 years, more carbon dioxide has been emitted than in all of previous human history. The concentration of carbon dioxide in the atmosphere has gone from 250 parts per million to 410 parts per million. And the worst is that the amount of carbon dioxide that is being emitted is still rising. It was larger by 2.7% in 2018. The Earth is on track to warm by about 1.5 degrees centigrade, 2.7 degrees Fahrenheit. That's 50% more than the warming that has taken place so far. So we can expect that the effects of global warming will be roughly 50% worse or worse in the future. That is expected to be by approximately 2050. When will it end is the question. When will the Earth stop warming? Will it reach 2 degrees centigrade by 2100 or will it stop? No one knows the answer to that question because no one knows when humanity will wake up and stop emitting more carbon dioxide than the Earth can absorb. This is a movie mainly about energy. But before we go into energy production and the other related subjects, I wanted to spend some time talking about the effects of global warming. First, ocean rising. Why is it rising and how much is it rising? It's rising very simply because the warming of the Earth is causing land-based ice to melt. Glaciers are shrinking and the ice cap on Greenland is getting smaller and the ice in Antarctica is shrinking. How much has it risen? About 4 to 8 inches in the last century, but it is expected to rise at a more rapid rate in the future. The Intergovernmental Panel on Climate Change, a group of scientists from many countries, forecasts a rise of 1 to 3 feet by 2100. That is enough to flood several cities along our East Coast. The IPCC members privately say that their estimate is low. Another entity forecasts a rise of 6 feet, and another group forecasts a rise of 23 feet if the Greenland ice sheet melts completely. That would flood most of the world's great cities and create millions, probably tens of millions, of climate refugees. Some analysts predict war as a result, possibly just civil war, but no one knows. Some other bad effects of global warming are an increase in the intensity of hurricanes. Hurricanes Katrina in 2005 killed 2,000 people and cost $100 billion to clean up. Hurricane Sandy in New Jersey and New York killed 233 people and cost $70 billion to clean up. Hurricane Harvey was more serious than Hurricane Sandy. One can expect more hurricanes and more severe hurricanes in the future. Flooding has increased as a result of global warming. The warming of the atmosphere causes an increase in evaporation of water from the oceans. Very simply, causes more rain to fall in some areas. That has created terrible problems in some places, among them in the Midwest in the United States very recently. Along with flooding, the changes in the weather patterns of the world have caused droughts in some areas. Terrible droughts ruined farming areas, causing food shortages in some places. And in some places in the world, it is actually becoming so hot that human beings cannot live there. Some areas are close to that. The other thing that has been affected a great deal by global warming are coral reefs. They are extremely important. It is estimated that 1 billion people in the world get the protein they need from fish that require coral reefs in order to live. The warming of the oceans has killed about half of the world's coral reefs, and that will only get worse. There are other effects of global warming which I would like to mention, but not go into detail about because I want to cover the issues of energy. They are, among many others, increased forest fires. You've all seen what happened in California in the past year. Extinctions. It is now estimated that there will be 1 million species of plants and animals becoming extinct as a result of global warming. There is also the spread of tropical diseases. Now that I have frightened and depressed you terribly, let me say that the book that I previously mentioned ends with a view of most climate scientists that there is still time to alter our energy systems and prevent the most dire effects of global warming. It is a political problem, not a technological problem. We must act, but to act intelligently, we must understand the issues. So let's turn to the next issue, part 2, what causes the Earth to warm? What causes the Earth to warm? The simple answer is the greenhouse effect. How does the greenhouse effect work? The sun warms the Earth radiates and reflects some of that heat out into space. The greenhouse gases absorb some of that heat and re-radiate it back to the Earth. It's a little different from a blanket. It's really the re-radiation of the greenhouse gas back to Earth that causes the problem. It's like what happens in a car. When the sun warms the seat of the car, the seat radiates some heat to the roof of the car, which radiates some of the heat back, and that causes the car to get really hot. What if there were no greenhouse gases? The answer is that the Earth's temperature would be about 0 degrees Fahrenheit, too cold for liquid water, and therefore there would probably be no life on Earth. What are the greenhouse gases? Well, obviously the one we all know is carbon dioxide. There's also methane, CH4, and nitrous oxide, N2O. The greenhouse gases, other than carbon dioxide, are much less in volume. So the problem is caused by carbon dioxide. Next question is, how do we know the carbon dioxide content of the Earth? That it has risen from 250 parts per million to 410 parts per million. How do we know the old level of carbon dioxide in the air? And the answer is that snow that fell in Greenland and in Antarctica, much of that snow never melted and became very thick ice. Scientists have put pipes into that ice, and the ice core has little bubbles of air in it, and those can be analyzed. Those bubbles have not changed since before 1880, so one can get an analysis of the carbon dioxide content of the air in the past. How do we know that the rise in the temperature of the Earth comes from the rise in carbon dioxide? Take a look at this graph. It shows that as carbon dioxide has risen, the temperature of the world has risen almost in lockstep. Climate scientists are convinced that the rise in temperature of the Earth is due to the rise in carbon dioxide and that is caused by human activity. I leave it to you, the viewer, to figure out why there are still some people that deny that the Earth is warming and deny that it's caused by human activity. Let's turn next to part 3, how electricity is made and the fossil fuels that are employed to make electricity. In the 1820s, Michael Faraday, an English scientist, developed the principles regarding electricity and magnetism, which are very closely related. For our purposes, what we need to know is that The way electricity is produced is by pushing wires through a magnetic field. This was one of the discoveries of Michael Faraday. Take a look at this schematic. The outside, the stator, are magnets. The inside of the device is a rotor. The rotor is a group of wires. When the rotor is turned, the wires are pushed through a magnetic field, and when a complete circuit is made, electricity flows. I also have here a toy generator. The inside of this device is a coil of wires. When two magnets are placed outside of the coil of wires, when the coil of wires inside the magnetic field is turned, a light lights up, as you can see. A commercial generating plant is simply a larger version of the toy. The electricity travels through wires wired directly to the plug in your home. The question is, what makes the wires go through the magnetic field in a commercial generating plant? Take a look at this schematic. It shows a very simple system, which is a heat source heats water, makes steam. The steam turns a turbine the same way wind would turn a windmill, and that turns a rotor, group of wires, which makes an electric current. So the question is, what is the fuel that produces the heat that makes the steam that turns the turbine? And that is where the problem lies. That brings us to our next topic, which is fossil fuels. So what powers 80% of our electrical production in the United States? Fossil fuels. What are they? They are the remnants of plants that lived between 350 and 300 million years ago in a time period called the Carbonaceous era. When those plants died, they fell to the ground. They were buried by other plants, by lava from volcanoes, ash from volcanoes, and by rock that washes off mountains. Gradually, over millions of years, that material sank into the ground where there is heat, and the material was cooked without access to oxygen, and that formed the coal, oil, and natural gas that we take for granted today. Those materials took tens of millions of years to form. Humanity has been taking them out of the ground for about 250 years, a blink of an eye in the Earth's history. So let's turn to the individual kinds of fossil fuels. First, coal. Why is coal so bad? It has a bad reputation. The reason is that it's almost entirely carbon. Therefore, when it is burned, it only produces carbon dioxide. It produces the most carbon dioxide for each amount of heat that is produced. Coal-fired electrical generating plants produce phenomenal amounts of carbon dioxide, roughly 700 tons of carbon dioxide per hour. It boggles the imagination. What else is bad about coal? It contains sulfur dioxide, which combines with water in the air, and that produces sulfuric acid. That falls to Earth as acid rain and kills fish in rivers and lakes. Probably the worst thing about coal is that burning it creates fine particulates which cause lung disease. It is estimated that coal causes 24,000 deaths per year in the United States alone, and in China, 366,000 deaths per year. The other aspect of coal is that it is extremely capital intensive. By that I mean coal miners, owners of coal mines, spend a great deal of money on capital equipment and very little on labor. That is illustrated by the largest machine in the world called the Bagger 293. Here it is in a photograph. It can mine 350,000 tons of material per hour. Also boggles the imagination. That machine takes only 5 people to operate it. The coal that is mined in that fashion is brought to generating plants in trains that are 1 mile to 1.5 miles long that require only 2 people to operate it. So the viewpoint that the mining of coal helps employment in the United States is not correct. Let's turn now to oil. Oil is formed when plants in swampy areas die, fall to the ground, and are buried along with zooplankton. Zooplankton are animals that are like jellyfish. They float on the surface of the water, and when they die, they sink to the bottom of the ocean. And as with coal, they are buried by other plant material and by rock that washes off mountains. And after tens of millions of years of being buried in that fashion, crude oil is formed. That oil is obtained simply by drilling into the earth, and if the oil is there under pressure, it comes to the surface by itself. If it is not under pressure, it is pumped out. Crude oil is a mixture of many different substances. They are separated from each other in refineries. Some of those refineries are in New Jersey and are visible from the New Jersey Turnpike. Gasoline is just one of the components of crude oil. So what's wrong with oil? What's bad about it is very simply that it is a fossil fuel. What's good about it is that it is in liquid form, and liquid is needed to power the internal combustion engines that exist today. Solids don't work. They don't burn fast enough. Planes, cars, buses, etc. need a liquid fuel. There is an enormous amount of coal in the world. It is estimated by some people that it could last 250 years, but oil is limited. One company, BP, estimates that there is only 50 years left of reserves of oil, after which it will start to run out, and of course, when that happens, it will become very expensive. The gasoline that powers our internal combustion engines, of course, emits an enormous amount of carbon dioxide, and what is needed is some replacement for that whole system. That is being developed. There are now electric cars. China manufactures more electric cars than the rest of the world combined. Companies that make cars are starting to prepare to manufacture them en masse. Now, if an electric car is charged from electricity that comes from a coal-fired plant, then there is still a carbon footprint to the electric car. However, the carbon footprint of an electric car is about half that of a gasoline-driven car. Hopefully, in the future, there will be plants that produce electricity without also producing carbon dioxide, and then electric cars will be an ideal answer. Some countries have actually banned the sale of non-electric cars starting at a certain time. India and Germany have banned the sale of non-electric cars starting in 2030. England has banned it starting in 2040. We, of course, have not done so. Next, let's turn to our last example of fossil fuel, which is natural gas, also formed inside the Earth, but the natural gas was formed when material that was buried under pressure decomposed. Natural gas is composed almost entirely of methane. Methane is formula CH4. So let's talk about how it's gotten from under the ground, because that is a problem. The way it's gotten is by drilling a pipe into the ground and then making that pipe go horizontally through the area that contains the natural gas. Then an enormous amount of water is pumped into that space under pressure, along with about 50,000 gallons of explosive chemicals. The material is then exploded, that fractures the rock, and then the gas can be gotten. That is the process called fracking, and it is very controversial. On the positive side of fracking, it is cheaper than oil and has brought about the fact that the United States is now independent of other countries in oil. Other advantage of it is that it produces more heat for each amount of gas that's burned than coal does. And the reason for that is because of its formula being CH4. So if you take CH4, as in the equation that's shown on the screen, and you burn it with oxygen, you get carbon dioxide and water. So some of the heat is produced by burning hydrogen that produces water. So less CO2 is produced than when coal is burned for each amount of heat that is produced. For the reasons I've just described, natural gas has been termed a transition fuel. That is, it is a fuel used in transition from coal to sources that are non-polluting. There are other problems with fracking. The enormous amount of water that is used, about 1 million gallons per well, has produced water shortages in some areas. Also, the chemicals that are put into the well have polluted some drinking water. In Pennsylvania, there was actually the products of a well that caught fire. Lastly, there is an unexpected problem. The explosions have caused an increase in low-level earthquakes. Let's turn now to the much better stuff, which is saving energy and non-polluting energy sources. This is the optimistic part of the film. Saving energy can be done very, very easily, and you probably can think of 1 million ways to save energy yourself. The first and most obvious is simply to turn the lights off when you're not using them. But this should not just be in homes. There are businesses, stores that leave their lights on 24/7. You can take a look at a picture of New York City in the dark, and you can see an enormous amount of light. Things like hallways are kept lit 24/7. Hallways in apartment buildings can be easily made to turn on the lights only when someone is in the hall. Similarly, escalators in the subway work 24/7. They could easily be made to work only when they are in use. Some other means of saving energy are to increase the insulation in all buildings. There is better insulation being developed, but it costs money and there's resistance to it. Cars can be made by rules, by regulations and laws to have better mileage. That is still happening in some places, in California in particular. Reusing goods can save the energy that is used in producing the goods. Of course, the laws and regulations that would require some of these things to be imposed are opposed by the coal, oil, gas, and utility companies. Now let's turn to the really optimistic stuff, which is the non-polluting sources of electrical power. First up, solar power. You've all seen solar panels, but how many of us know how a solar panel is made and how it works? Here is a schematic of it. It is made out of silicon, an element that comes from sand, so it will never run out. The silicon is melted and poured into 2 thin layers. One layer has a substance added to it that emits electrons. The other layer has a substance added to it that absorbs electrons. The 2 layers are put together, one on top of the other. Wires are put into each layer. The layers are separated by a semiconductor, and when a particle of light, a photon, hits the layer that can emit electrons, an electron is emitted. If a complete circuit exists, the electron travels through the wire and we have an electric current. The obvious defect with solar panels is that it only works when there's light. So at the present time, it needs backup. And that backup today is mostly from coal-fired plants. Hopefully that will change. The other problem with solar panels is that if you have many of them, it uses a lot of land and it displaces some farmland. The best place to put it would be in the desert where it would not displace farmland. There are experiments in seeing if the panels can be put on floating devices in lakes. that is ongoing research. The cost of solar panels has dropped enormously in the last 10 or 12 years. And the cost of electricity produced by solar panels is now competitive with fossil fuels and some say even cheaper. The solar panels cost money to install, but after they are installed, after the loan that is usually taken out in order to pay for the installation, the power is completely free. Next up, wind power. Wind has been used to power things since ancient times. It has powered the grinding of grain, powers sailing, it powers electricity production since the late 19th century. Here is a schematic of a wind turbine. It works very similarly, in essence, to any other generating plant, which is wires are pushed through a magnetic field. The turbine turns a rotor, which is inside a magnetic field, and current is produced. The complexity is, of course, in finding the right size and shape of the wind turbines. It takes a lot of research to come up with the best ways, and also to have the best way of causing the whole device to rotate so that it best picks up the wind. There is obviously a problem with wind turbines, similar to the problem with solar panels, which is it only works when there is wind, so it needs backup. The best places to put it are places where there is steady wind. Offshore is one, but turbines placed offshore are more expensive. Sometimes they're placed on mountain ridges. They get steady wind. Some people complain that the turbines are unsightly. Other people find them beautiful in their own right. They have an additional problem, which is that they are noisy, and therefore they can't be too near where people live. On the positive side, very little land is used, and wind turbines can be placed in farms and not displace much farm area. They do require maintenance since there are moving parts. Next up, nuclear reactors. Unlike all the other kinds of power we have described, the source of power in a nuclear reactor does not originate with our sun. It originates with the element of uranium and some other elements, but we'll stick with uranium. Uranium is found in the earth, and it gradually decomposes into smaller atoms. It is the heaviest naturally occurring atom. The uranium in the earth produces a small amount of heat all the time. When the uranium is mined and purified and put together with other uranium, a great deal of heat is generated. That heat is used to power a generating plant, just like a fossil fuel plant, except of course the source of the heat is the decomposition of uranium. The use of nuclear power is very controversial, even in the environmental movement. Some environmental scientists say it's necessary to stop CO2 emissions. Others say it has too many negatives and it should not be used. So what are the negatives? The first negative is that it can be very dangerous. The reaction of the decomposition of the uranium when it's put together with other uranium generates an enormous amount of energy. The reaction needs to be slowed down. It is slowed down by pumping water through it or with graphite, that is the substance in pencils. And if the mechanism that slows down the reaction breaks down, an enormous amount of heat is generated and the container of the radioactive material melts, and then radioactive material is spewed into the environment. There have been 3 serious accidents, one in Pennsylvania at 3 Mile Island, another in the Ukraine at Chernobyl, these are famous, and another in Japan at Fukushima. The one at Chernobyl was the worst. 31 people were killed at the time of the accident. 4,000 more died of cancer caused by the radiation that was emitted. So the question is, can it be made safer so that it's not dangerous? There have been an estimated 100 other accidents that are called serious, but have not resulted in the emission of radioactive material. About 20% of the electricity in the United States is produced by nuclear power. Another problem with nuclear power is that there is a fear that it can be stolen by terrorists and made into an atomic bomb. There is a group that breaks into nuclear power plants intentionally and successfully just to demonstrate how vulnerable they are to theft. And the last problem with nuclear power is that the waste materials are themselves radioactive and need to be stored away from people basically forever. As yet, there have been no such safe storage areas developed. In the United States, the radioactive material is simply kept at the site of the nuclear power plant. This could change in the near future because Finland is developing a very large facility from which it will earn billions of dollars, and it's a very small country, so the people there will get rich. The advantage of nuclear power, of course, is that it is usable 24/7, unlike solar and wind. It also does not emit any carbon dioxide, and the uranium that is needed for it is abundant. It can even be gotten from seawater, although that is not yet economical. So let's turn to another part, more non-polluting solutions. Next up is hydroelectricity. That is electricity formed by the movement of water downhill. So the root source of that power is the combination of the sun that evaporates water from the oceans that falls into rivers and lakes, and the force of gravity that pulls the water downhill. In order to harvest that power, a dam is built and a reservoir is formed, and considerably below the surface of the water, a pipe is inserted through the dam called a penstock, and the water that flows through that pipe is used to turn a turbine that works the same way we have seen before. There are disadvantages to hydroelectricity, the main one being that areas that are flooded when reservoirs are formed were formerly occupied by farms and people who are displaced. There are, in the United States today, no places that are left to build a large dam like the one in the picture, the Hoover Dam, so there probably will not be any more large dams and large reservoirs built. There will probably be smaller dams and smaller reservoirs built to serve small communities. The other disadvantage of hydroelectricity is that the dams disrupt fish stocks. There are fish that are accustomed to swimming upstream to spawn, and they are prevented from doing so, and fish that live downstream from the dam are much reduced in number, and fishermen suffer. An advantage, of course, is that the electricity that is produced is very inexpensive, about half the cost of electricity in New York. Droughts can affect dams. In Brazil, a drought reduced the productivity of one of their main power sources, and the climate changes that are taking place all over the world could affect other countries. Next up is biomass. What is biomass? Well, biomass is very simply plant material that exists today that grew recently or is still growing. Wood, of course, is the original biomass, having been burned since prehistoric times, and it's still burned today for energy in underdeveloped countries. The material that constitutes the biomass is used in fermentation to create a liquid. Fermentation of many things produces ethanol, which is the alcohol that maybe only your parents and maybe you too drink with wine, beer, and such. Ethanol in the US is produced by fermenting corn, and the ethanol is added to gasoline, and the gasoline that comes out of the pump in a gas station is 10% ethanol. The result is that the gasoline is slightly less environmentally harmful than if it had no ethanol. The fermentation of biomass is very important because it creates liquid fuel, which, as we saw earlier, is needed for internal combustion engines. The cars, trucks may be able to be run on electric motors in the not too distant future, but planes may always require a liquid fuel. So the question arises, since burning fermentation products does emit carbon dioxide, why is it environmentally beneficial? And the answer is that the carbon dioxide that is emitted by the burning of the fermentation material comes from plants that grew recently, and if they are replanted every year, the theory is that the plants have absorbed the same amount or close to the same amount of carbon dioxide that is emitted when they are burned as the plants are growing in photosynthesis. There are scientists that dispute that and say that only about a third of the emissions from ethanol produced from corn is absorbed by the corn as the corn is growing. There is another problem with using corn to produce fuel, which is that it has created a food shortage of corn for export. And Mexico used a lot of that corn and now has a shortage of corn that comes from us. It is possible that other biofuels, biomass materials will be developed that do not have the same problem of using too much land, like kelp and algae that could be grown in seawater, which could be very abundant, very cheap, and not displace farming. Next up is geothermal energy. What is that? It's energy that comes from under the ground. Where does that originate? It originates from the time when the Earth formed by the force of gravity pulling together the molecules and rocks and other material that formed the Earth. When that material bumped into each other by the force of gravity, heat was produced. The Earth has been emitting that heat into space for 4.5 billion years, but there is still a lot of it under the ground. The center of the Earth is estimated to be 12,600 degrees Fahrenheit. Near the borders of tectonic plates, the heat that is under the Earth can sometimes be easily harvested simply by having pipes inserted. That is done in the Geysers geothermal field in California and in the Philippines and in Iceland. Sometimes the pipes that are inserted result in steam coming out directly, and that steam can be directly used to turn a turbine to make electricity. Other times, it is hot water that comes out of the Earth, and that is transmitted to homes and businesses to provide space heating. In Reykjavik, Iceland, that is done, and 90% of the homes in that city are heated by geothermally heated water, and it's free. The cost of geothermal energy is very varied, not yet economical except in some places. This could change over time, of course. Next up is tidal power. What is the original source of that kind of power? Only the force of gravity. The moon, and to a lesser extent the sun, gravitationally pull on the Earth. This causes the level of the oceans to rise at the place closest to the moon. As the moon revolves around the Earth, and as the Earth turns, the place where the gravitational force is the greatest changes, and the level of the ocean changes in response. At shorelines, that is seen as tides, which are very regular and can be used to generate electricity. There are devices that exist where the incoming water can turn a turbine, and then as it goes out, it can turn a turbine that's made to turn the other way. There are two large tidal power stations in existence. One has been in existence since 1966 in France, Another is in South Korea. That one is the largest in the world. It opened in 2011. The other way of harvesting that kind of energy is to build a dam at the mouth of a river. And then the tidal forces will cause water to go into the reservoir, and as it goes in and out, it can turn a turbine. Our last topic is storage of electricity. We have seen that there are sources of power that are not regular, wind and solar, and they produce more electricity than is needed at some times, and either none or less than is needed at other times. So there is a need for storing electricity. How do we do that? Well, one way you all know, which is batteries that exist all over the place. They range in size from the smallest batteries that power your cell phone, even smaller than that, batteries that power a hearing aid. I'm not sure how big they are, but they're probably almost microscopic, to batteries that power automobiles that can run 300 miles, to even larger batteries that power some homes. But that is small-scale storage. Utility companies store electricity in a completely different way, by pumping water from a lower area into a reservoir when there's excess power, and then drawing it out of the reservoir when the power is needed. The problem with that is that it only works in a hilly area. And as we have seen, it's very difficult to build new reservoirs because the environmental and human impact is too great. There are two large storage facilities in the United States, one in Michigan and one in Virginia, and the future may bring more of that. Let me close by saying that global warming is the worst crisis of our era. It is also something that presents an opportunity for young people to find their life's work in meaningful, useful work. Let me end on the same optimistic note that David Wallace Wells ends in his book, which is, there is still time to alter our energy systems and prevent the worst effects of global warming. It is a political problem as to whether and how we act.